The teleconference line crackles at 11:27 p.m. on January 27, 1986. Roger Boisjoly, an engineer at Morton Thiokol, has stared at the same data for 3 hours. The O-rings, rubber seals between solid rocket booster segments, have never been tested below 53 degrees Fahrenheit. Cape Canaveral's forecast, 28 degrees. He writes, "If the primary seal fails, the secondary seal will not pressurize. Loss of crew and vehicle." The datasheets are slick with fingerprints. Boisjoly has 3 separate analyses in front of him. Erosion charts from Flight 51C the previous January, where the O-rings were visibly blackened on recovered segments, a thermal model showing the rubber losing its resilience below 40 degrees, and the latest telemetry from the night's ice inspection revealing a layer of frost on the water pipes near the booster field joints. Across the table, Bob Eberling, his colleague, has been chain-smoking for an hour, the ashtray overflowing. The room smells of stale coffee and anxiety. Outside the conference room window, Utah's winter sky is clear and bitter. The temperature at the plant is already 14 degrees. Boisjoly knows that every hour closer to dawn means the launch pad temperature could drop even further. In our timeline, NASA managers overruled him. The launch proceeded. 7 astronauts died on live TV. The space program entered a dark age that lasted a generation. But in this timeline, something different happens. A mid-level administrator named James Beggs, tired, overworked, carrying a stack of unread memos, pauses at one. The Morton Thiokol recommendation, stamped urgent, sits on top of a pile of Shuttle manifest summaries and budget projections. He is alone in his office at NASA headquarters, the fluorescent lights humming. His coffee has gone cold. He reads Boisjoly's handwritten note photocopied onto the memo. Loss of crew and vehicle. Beggs is not an engineer. He is a manager, a political appointee who came from the aerospace industry. But he has a wife and daughters, and he knows Christa McAuliffe's name. Everyone does. He picks up the phone. Delay the launch 72 hours. Let the weather warm up. The words are not heroic. They are tired, reluctant, bureaucratic. But they create a cascade. The launch director is furious. The schedule slips. The networks have to fill airtime with replays of earlier missions. But on the ground at Kennedy Space Center, the workers shrug. Another delay. They have seen dozens. That 3-word sentence changes everything. On January 30th, 1986, Challenger lifts off from Pad 39B at 11:38 a.m. Clear sky, 42 degrees. The O-rings hold. The boosters burn cleanly, their joints sealed by rubber that has been warmed by the Florida sun for 2 extra days. On the ascent, the camera shows no plume of smoke from the side of the right booster. In mission control, Boisjoly is watching from the viewing gallery, his hands gripping the railing. At SRB separation, he silently counts the seconds. The boosters fall away, intact. He exhales. 7 astronauts, Dick Scobie, Michael Smith, Ron McNair, Ellison Onizuka, Judith Resnick, Greg Jarvis, Christa McAuliffe, reach orbit safely. For the first time in American history, a schoolteacher broadcasts a live lesson from space. Christa McAuliffe floats before a camera, holding a pencil and paperclip, demonstrating Newton's laws to 2.5 million schoolchildren. The footage replays for weeks. NASA receives 400,000 letters from students. Every classroom in America watches. In rural Nebraska, a 10-year-old girl writes to Christa, "I want to be an astronaut like you." That letter is saved, filed, eventually answered 3 months later with a signed photo from orbit. The agency, struggling for relevance since Apollo, becomes the most inspiring institution in America again. The political consequences are immediate. Ronald Reagan, riding national pride, announces a space exploration initiative in his 1987 State of the Union. Shuttle funding doubles. The Hubble Space Telescope, delayed 3 years after Challenger in our timeline, launches on schedule in 1990. When its primary mirror is found flawed, the fix takes 18 months instead of 3 years. A repair mission launches in 1991 with a crew that includes a former schoolteacher, Christa McAuliffe herself, now a veteran astronaut. Hubble returns images that stun the world, the pillars of creation, the Eagle Nebula, the deep field showing galaxies where no light should exist. NASA's credibility is unquestioned, But the real change is geopolitical. The Soviet Union is collapsing. In our timeline, a weakened NASA couldn't seize the moment. Here, America's space program is ascendant. When the Berlin Wall falls in 1989, George H.W. Bush offers the struggling Russian space program a lifeline. Join us in building a permanent space station as junior partners. Russia accepts. The International Space Station begins assembly in 1993, 5 years early. The first modules, Zarya and Unity, are linked in orbit by shuttle crews that include Russian cosmonauts trained in Houston. By 1996, first modules are habitable. By 1998, a crew of 7. Without a catastrophic shuttle loss, the launch schedule is aggressive. The station is completed by 2001, a full decade ahead. Larger, more ambitious, more scientifically productive than the one we remember. Its solar arrays stretch wider than a football field. The laboratory modules are equipped for experiments in protein crystal growth, materials science, and human physiology. The crew sees 16 sunrises a day. The cultural shift is subtle, then overwhelming. Children born in the 1990s grow up where space exploration is routine. They watch shuttle launches like earlier generations watched baseball. NASA's budget never faces brutal cuts. A Mars mission becomes a concrete goal. In 2004, President John Kerry, elected in a close race, announces the Mars Initiative, a human landing by 2025. The Columbia disaster never happens. Without post-Challenger safety culture collapse, the foam debris issue is caught and fixed in 2002. During routine inspection of ET-117, a technician notices a piece of insulating foam that looks larger than usual. The anomaly is reported, analyzed, and within 3 months, all subsequent tanks are redesigned with a reinforced bonding layer. Columbia flies until 2015, retired alongside the rest of the fleet. No astronauts die in flight. The safety record remains unbroken. By 2020, NASA has a permanent moon base, Armstrong Station, with a crew of 12, a greenhouse growing lettuce and tomatoes under LED lights, and a mining operation extracting water ice from lunar poles. The ice is split into hydrogen and oxygen for rocket fuel. The base is powered by solar panels that lay flat on the Mare Tranquillitatis, glinting like silver foil against the grey regolith, funded by a government that never lost faith in its space program. The private sector emerges later, differently. SpaceX launches Falcon 9 in 2010, but NASA is still the dominant customer. Elon Musk's Mars ambitions are channeled through government contracts. Blue Origin builds lunar landers for NASA. The space economy is collaborative, driven by national ambition, not billionaire ego. And yet, there is a cost. The space program's success breeds complacency. Public interest settles into quiet acceptance. The Mars mission, announced with fanfare in 2004, faces repeated delays, pushed to 2030, then 2035. Political will, without tragedy to galvanize it, falters. The first humans set foot on Mars in 2042, not a triumphant moment, but a cautious, bureaucratic achievement. The landing site is Jezero Crater. The first words are not one small step, but a quiet, "we have touched down." The footage is streamed to Earth with a 15-minute delay. On Earth, people watch it on their phones, then go back to their day. In our timeline, Challenger broke something, but it also created a hunger for redemption. In this timeline, there is no wound to heal. The dream moves more slowly. On January 30th, 2026, 40 years after that cold morning, a granddaughter of Krista McAuliffe stands on the moon. Alice McAuliffe-Chan, 34, a geologist, looks up at Earth, blue and fragile. She thinks of her grandmother, who taught from orbit and lived to see her grandchildren reach the stars. The 7 astronauts survived. Because they did, humanity didn't stop reaching. It just took a different path. Alice kneels and scoops lunar dust into her bag. She knows the story of her grandmother's flight by heart. She knows that in another version of history, her grandmother never became a grandmother, that she herself might never have been born. She carries this knowledge lightly, like a stone in her pocket. She looks up at Earth and wonders what lessons hide in the cold shadows of this crater, whether humanity will learn them without first breaking something irreplaceable. The answer, she thinks, is written in the dust beneath her boots. It will take another 100 years to read it.